Welcome you everyone to this complete OOPS concept in Java with notes where I will teach you every small details in OOPS from starting to end. With this video, I have attached the notes as well so you can revise it anytime before your interview. In this video, I will cover the 4 pillars of OOPS, understand it deeply with examples and also help you to connect with the code you write and you become a better coder. Also, you can crack more and more interviews. This technique and examples has changed my life on how I see Java and I want these changes should come in your life too. So stick with me to the end of this video and I make sure that you become a pro in no time. Alright, so this is the entire index that we are going to learn in this entire video. First of all, we are going to learn the overview of OOPS. Then the very important, we are going to understand the difference between procedural programming and OOPS programming, right? Then we are going to understand the objects and classes in detail. Here I will take more time so that you understand it very clearly. Once you understand objects and once you understand classes, literally trust me, Java is nothing for you because it is all about objects and classes. So I will explain you very deeply this point. Then the 4 pillars start. The first pillar is data abstraction, the second is encapsulation, the third is inheritance, and the fourth is polymorphism. So all of this we are going to cover with example and with coding. Alright, let's start. So let me take a pen over here and cool. So we will come here and we will start with the overview of OOPS. Okay. So object-oriented programming is a programming based on the concepts of objects which contain data and method. Okay, so this is the typical definition where you see this definition everywhere and everywhere, right? But what does it mean? To understand what does it mean, what data means and what method mean, first of all we have to go back in time and we have to understand that before object-oriented programming came into the picture, what was there in the universe, which was procedural programming. So before understanding this data and method, first of all let's try to understand procedural programming which was there before object-oriented programming so that we can understand what are the limitations of procedural programming and why object-oriented programming came into the picture in real. Alright, okay, so forget about the table right now, whatever is written. Let me tell you how procedural programming used to work. So for example, procedural programming is basically, what is the approach? It is focus on functions. Okay, and object-oriented programming is focus on object. So what do we mean when we say it is focused on function? It means that, for example, I have a function, let's say void function 1. Okay, function 1, and it does some work. Or let's say we have a variable, car. Okay, we have a variable car. So now in procedural programming, what it is there? It is a linear type of programming. For example, when variable car is defined over here, this function can do some certain activity on this variable. It can change the variable, it can change the value of the variable, it can modify it and do anything. And then what will happen? This function 1 will pass this variable to another function which is called as function 2. Okay, and now function 2 will also do some modification on this variable and change this variable value of the variable. Alright, and like this it will pass on function 3, function 4, function 5. So what is happening over here, if you understand it clearly, you will understand that function 1 is changing the value of car and passing it to function 2, then function 2 is changing the value and then passing it to function 3, and then so on. It can pass to function 4 and function 5 and it goes on. So this was procedural programming. So what are the limitations in doing this type of programming? You understand, the car variable which function 1 has defined, it may have defined for function 1 use cases, alright, But when function 2 came into the picture and function 3 came into the picture, it modified the car variable, and the originality of that variable is lost now. Whatever changes was done by function 1, it is now lost. It is no longer visible in function 3 because function 2 has already modified it. Alright. So similarly, the function 4 will only know what function 3 has done. Function 4 will not get to know what function 1 or function 2 has done, right? I hope you're understanding this, right? So to solve this problem, this was the major problem. That's why oops came into the picture. Now I will tell you how oops run and how oops solve this problem, okay? But before that, whatever is written in the table, we'll just go through this. Procedural programming, it focuses on function. Data is separate from functions. It is less secure. Data can be accessed globally. You can see it is not secured basically. You can access this variable from function 2, then function 3 can access variable from function 2, function 4 can access variable from function 3, right? So there is no private, protected, public or such kind of thing. You cannot protect your variable that you don't want function X to see this variable, right? You cannot do that. Reusability, code reusability is limited. Why? Because you have to pass the variables. You have to pass the variable function by function. You cannot reuse the things, right? And what are the example? C and Fortran is the example. Now let's come back to our object-oriented programming and let's try to understand how object-oriented programming solve all of this value. And trust me, when you understand object-oriented programming, you will see the beauty what Java has done, what object-oriented programming has done. It's a beautiful concept. Alright, now let's come back to our object-oriented programming. So we understood the problem. Now to tackle this problem, what do we have? We have data and we have method. And now we will tackle the problem with the help of data and method. Let's go back and now let's talk about objects and classes and how objects and classes will improve our solution. Alright, what is a class? A class is a blueprint that defines attribute and behavior. And what is an object? It is an instance of a class that represents a real world entity. No problem if you haven't understood the definition, I will explain you. First of all, just understand what is object before understanding class. So object is any real world entity that has some property and that has some behavior. So object can be any real world entity, okay? And for a real world entity to exist, like how we are existing, how you are existing, how you and me, everyone is existing, everyone in this universe has certain property and certain behavior, and that's why they are called as objects. So just like you, me, everyone, not to objectify anyone, but object is something which has a property and a behavior in simple words. For example, a dog. A dog can be an object because dog can have certain property and dog can have certain behavior. What is the behavior of the dog? Dog will bark. And what is the property of the dog? Dog has 4 legs, 1 nose, 2 eyes, 1 tail. These are the properties of the dog. So if you say property, so probably we can say 1 tail is the property of the dog. And if you say behavior, barking is the behavior of the dog. Alright. So now we understand that dog is an object. So unlike dog, everything which has certain property and certain behavior will behave as an object. Alright. Okay. No problem. I hope you have understood till now. Until this, if you have any doubt, you can definitely write back in the comment section. But don't worry, I will explain you more. Okay. Cool. Now, when we say classes, okay, classes, you can understand classes are simple skeleton of an object. Okay, now I will explain you how classes and objects combine together to solve the problem which we faced in procedural programming. Let's create a class. Okay, let's create a class and let's try to understand that. Let's divide it. Okay, so we will create a class. For example, class animal. Okay, don't worry about the syntax right now. I am writing class animal. If you don't know, don't worry. I'm just creating a class. You just need to understand the concept. Don't worry about the keywords and the syntax right now. Class animal, and this is start and this closes over here. So now, for example, what animal does? Animal speak. So we can have a function void function, and we can name the function as speak. So every animal speak, right? So this is a function inside the class. Now what will happen when I create an object of this? So now, as I told you, this is my blueprint, or this is my skeleton of the object. So now every object created from this class will be created with the help of this skeleton only. For example, let's create one object named as dog. Just now we were talking about an object dog. So how do we create an object? We create an object with the help of animal, the class name, then you write the object name. So let's name the object as dog equal to new animal. If you don't understand the syntax, no worries. It is just a way how you create an object. So now with the help of this statement, I have created an object named as dog. Now dog is our object. So now with the help of dog, I can do dog dot speak. Dog dot speak. So are you understanding what has happened just now over here? I have created a skeleton called as animal, and animal can be anyone. It can be a dog, it can be a cat, it can be a lion, tiger, horse, zebra, anything. Alright, but all the animal will have a common behavior of speaking. Everyone speaks, but everyone's language is different, right? So that's why just how I have created animal dog object, and I can set dog.spark, and I can set bark. Okay, I can set what is the language, how does dog speak? Dog bark basically. Just like that, I can create another object animal cat. And what does cat do? New animal. Okay, I've created a new object called cat. Now what can I do? Cat dot speak. So since cat is created from animal object, so speak function will be available to cat also, and speak function is available to dog also, but the parameter can be different. It can be a meow. What does cat do? A meow. So just like that, are you understanding what has just happened? With the help of this skeleton animal, I have created a cat, and I have created a dog, and I can create zebra, horse, lion, tiger, anything. Just the behavior will be different, right? Now how does this solve the problem of procedural programming? Now what do? Now let's say if function 1, if you remember in our procedural programming, what was the problem? We have function 1, 2, 3, 4, and every function modifies a variable, and the originality of the variable was lost. But now what have we done? Now we have created two different type of variable. One is cat and one is dog, but the originality of the cat is meow, the originality of the dog is bark, and the originality of this no one can change, right? Because this has been created from animal class. If you understanding, this has been created from animal class, right? This has been created from animal class. So if function 3 or function 4 wants a new variable, he or she can create a new object called horse probably, and work on this object. So it doesn't need to touch the cat object, or modify the cat object or modify the dog object. If the function 3 or function 4 wants a new object, he or she can create a new object horse with the help of this skeleton. So this is the overall idea of classes and objects. Alright, now if you see the definition, you will have a better idea. What is a class? It's a blueprint or a template that defines the attribute and behavior of a object. Now I hope it is little bit of clear with you. If not, you can still drop a comment. I will again make a video and no time, and I reply to every comments. All right, cool. So after clearing this, let's move to our next topic, data abstraction. So from here, our exact 4 pillars of OOPS are starting. So what is the first pillar of OOPS? First pillar of OOPS is data abstraction. Don't worry, just stay in the video and be relaxed, and I will explain you everything. You will understand everything. Okay, data abstraction. What does definition says? Definition says it is just hiding complex implementation or detail and showing only the necessary feature, right? Okay, if you haven't understood anything in this definition, no worries. Let's try to take an example. For example, you own a car. Okay, you have a car. So what are there in the car? A car has a brake, an accelerator and a clutch. So let's not talk about everything. Let's just talk about the brake. What happens? So as a buyer, as a car enthusiast, what do? You just press the brake and you know the car will stop. Now, how does the car stop? Do you know the mechanism of that? Do you know the technicalities of that? So as soon as you just press the brake pedal, what happens inside, which wire goes where, and what exactly is happening inside? You don't know, right? You just know that I need to press and the car will stop. As simple as that. This is exactly what data abstraction is. What it says? It says that hiding complex implementation details and showing only the necessary features. What is the necessary feature in this? That I need to press the brake pedal and the car will stop. And what is the complex implementation? That inside, what is the wiring, what exactly happens in the engine, what exactly happens with the fuel and everything. You don't know that. So you just know that car will stop. This is called as data abstraction. Now let's talk about the same example in terms of Java and in terms of coding, how we can relate this and how data abstraction helps us to be a better programmer with time. So for that we will take a simple example. All right, let's take an example. For example, we will have void. Let's not take functions. Let's directly take a class. Okay. To take a class, you need to understand how you can achieve abstraction. You can achieve it using an abstract class or using an interfaces. So what happens? Don't worry about the syntax right now. Okay. What happens is you define an interface. Interface. Let's say interface name is animal. Okay, or since we are talking about car, let's take the name of the interface as car. Okay, so the name of the interface is car, and inside this interface, let's say you have defined certain functions. The function is void apply brake. Second function can be void, what can be apply use clutch, and probably a third function can be void turn on AC. So if you have coded a little bit in Java, you must have understood I am using a semicolon over here. If you see what I'm doing, I'm using a semicolon over here. I'm not writing the definition of the function, that what apply brake will do, what apply clutch will do, what turn on AC will do. I'm just defining the function. Okay, and this interface, this is exposed to the user. Okay, this is exposed to the user. So as a user, when you come here, what you will see, okay, I have only 3 functions available, that apply brake, use clutch and turn on the AC. So I can call any of the function. I can either call apply brake, I can call use clutch, or I can call turn on AC, and accordingly I will get the results, right? So this is what interface is. Right now there is no definition of the brake, that what will happen when you apply brake, what happens inside when you use clutch, and what happens when you turn on AC. So this is an incomplete code right now. How do we complete it? To complete this code, there will be a class, let's say car implementation, which implements car. So I have defined a class car imp which implements car. Now under this class you will write all the implementation and function definition. So as soon as I use implements and as soon as I use implements car, I have to implement all the three functions which are available in the car. So I have to implement apply brake, okay, and I have to write the definition over here, that what will happen, what wiring will go one first line, second line, third line, and it will return something. So this implementation, this is hidden from the user. Why it is hidden from the user? Because no one knows about this class called car imp. The user only knows that there is an interface called car and I can have this three function and I can call it, and I don't know what is the implementation. So this is a very fine way to hide your implementation and just expose whatever is required to the user. Okay, you have implemented apply brake. Like this you will also implement use clutch, and like this also you will implement turn on AC, right? So these are the things you will implement, and accordingly the user can use it. All right, so I have just shown you right now that how you can do it using interfaces. You can also do it using abstract classes, but that is something advanced. Okay, with that we will cover in probably some other video. All right, but the idea should be clear that what we are doing, we are hiding the data and we are only showing the necessary things. So what is the purpose? Purpose is reduce complexity and increase efficiency for users of the class, right? Cool. If you have still any doubt, you can still write down in the comment section. All right, let's move ahead a little bit and let's talk about encapsulation. It's one of my interesting, one of my favorite oops concept as well, encapsulation. What does it do? It's a very sweet example. I will tell you how it works. All right. For example, let's take our previous example. Let's take a new, or let's take a new example. Let's say we have a class called car. Okay, not function, it's a class called car, and inside car let's take same functions, apply brake, and let's take only two functions, turn on AC. All right, cool. So when we say apply brake and turn on AC, what does it actually mean and how do we encapsulate this? All right, cool. Now we will create certain objects of the class, like, or let's do one thing to understand it better. Let's not use functions for this example. For encapsulation we will use variables. That will help you to understand in a better way. You can understand it with functions as well, but a variable can be a better example in this case. So let's take a variable first of all. Okay, let's define a variable called probably stop the car. Next use a variable, this is a variable not function, stop the car. Next we can use another variable called start the car, the car. Okay, there we have two variables defined. Cool. All right. So now when we create an object of this class, for example car, we have a new object called Audi, which is equal to new car. Okay, this is our first object. Let's create one more object, car Suzuki is equal to new car. Correct? Okay. Now what does encapsulation says? Encapsulation says that binding data or binding variables and method into a single unit and restricting direct access to the data. This is a very important term that you need to understand, that restricting direct access to the data. What it exactly means when we say that we have to restrict the direct access to the data. Right now, when we have var, when we define a variable stop the car and we have defined the variable start the car, this is by default a public, right? And this is also by default public. So if I have certain more other classes, so when we created two different objects, Audi and Suzuki, and by default this is public, so this variables stop the car and start the car, this is accessible throughout entire classes. Anyone can come and anyone can change the value of this car. So stop the car, we can change the value, probably anything. This variable is not very relatable. Let me just change the name of the variable so that it is more relatable. Let's name this variable as color. Okay, a very simple example, a color. And probably what other features can a car have? Sunroof. Okay, a sunroof. Sunroof is present or not, yes or no. So now when you see, anyone can come and anyone can change the value of this variable called color. So if it is public, right, let's say I have a class X, it can certainly call this variable and change the value. I have a class Y, it can certainly call this variable and change the value. Okay, so I don't want to do that. For that we will use encapsulation. And how encapsulation works, I'll just remove this. I will not use it as public anymore. I will make this variable as private, and I will make this variable as private. So when I make this variable as private, now class X cannot access color. It cannot access color. Class Y cannot access sunroof or color. In fact, any variables of this private variables cannot be accessed. Now, when I created a new object called Audi and I created a new object called Suzuki, they need to change the color. So to change the color of this, I will have two functions, which is getter and setter. So I will define a function called get color, and I will define a function called set color. So what will happen when I define a function called get and set color? Now what I can do Audi dot set color. Okay, and I can set anything. For example, pink. I have set a color called pink. Now when I do Audi dot get color, it will return me, what it will return me? It will return me pink, because now you can understand that every object has a unique color, right? So Audi will have a unique color called pink, and Suzuki can have unique color called white, right? So just like that, this is the benefit of encapsulation, that Audi will have a unique color pink. I can Audi dot set color pink. Similarly, what I can do, I can Suzuki dot set color, and I can make it as white. So whenever I do Suzuki dot get color, what I will get? I will get white. And when I do audi.getColor, what I will get? I will get pink. So this is how encapsulation comes into play, and it creates a copy of everything, right? So you can see we have only one class, the skeleton is only one, the car, right? And with the help of this skeleton, I have two different variables named as Audi and named as Suzuki, and I can create as many as I want. It's all up to me, right? So this is what entire encapsulation is. So now what we have done, we have privatized. Okay, we have privatized. It's no more public, it's no more accessible. So we have restricted the direct access to the data, right? So what we have done, we have achieved by declaring the variable is private and providing public getter and setter. This functions get color and set color should be a public function, so that one can come and modify it. But now the modification is done on the base of object. If we have only color and only sunroof, I don't know it is of Suzuki or if it is of Audi. But when I have object, I know that okay, the Audi is setting the color to pink and Suzuki is setting the color to white. This is what entire encapsulation is. Cool. Alright, so if you have any doubt, you can definitely comment. Let's move ahead and let's talk about inheritance right now. Inheritance. So basically, forget the definition, it's a simple thing. I have a class A, then I have a class B, then I have a class C. So just like in real life, you have a parent and you have a child. So a child can inherit the qualities of a parent. Okay, a child can inherit the qualities of a parent. So just like that in our Java, if we have a class A and if we have a class B which extends, this keyword is important, which extends class A. Now what will happen if we have any variable or function which is defined in class A, let's say use break. If we have this function in class A and I'm using this keyword called extend, now what will happen, I will create a new object of class B. So how to create a new object of class B? The class name, then obj object is equal to new B, right? So now I have created an object obj which is of class B. Now you can see class B has no function inside, but class A has a function called use break. So when I use extends, it means it is a child of class A. I can do B dot, sorry, not B, I have to do obj, which is the function, which is the object of B, obj dot use break. So if you try to understand what has happened just here, use break was not present in class B, use break was present in only class A. But then also with the help of B's object, I can use break because it's a child of class A and it's inherited. So I can definitely use it. There is no problem in that. Right? Okay. Now, do you think if I define a variable of A, alright, and there is a function present in B, let's say use AC, okay, use AC, can I do A dot use AC? No. Why no? This is a strict no, because A is the parent. Parent cannot inherit from the child, but child can inherit from the parent. This is the very typical example that you might be asked in interviews as well, right? Cool. So this was the overall idea of inheritance, right? What are the 4 types of inheritance which are supported in Java? So we will have single inheritance, then we will have hierarchical inheritance, then we will have multi-level inheritance. Multi-level inheritance. Okay, we have one more type of inheritance called as multiple inheritance, but that is not supported in Java. We cannot use multiple inheritance in Java. It's a strictly no. I will explain you why this is a no. Because of this a problem arises which is called as a diamond problem. Let's try to understand what is diamond problem. Okay, and let's give it some time. So before that, what is single inheritance? We have a single class A. From A, B is inheriting, that is a single inheritance. What is hierarchical inheritance? We have a class A and we have a class B and we have a class C. So from A, B can inherit and C can inherit. And what is multi-level inheritance? Multi-level inheritance is simple. We have a class A, we have a class B, we have a class C. So it's a multi-level, right? It works like this. But now let's talk about the diamond problem. I need to have a new page. Okay, so we will talk about diamond problem a little bit and why multiple inheritance is not allowed. We will talk about that. Okay, cool. So diamond problem is basically, first of all, what is multiple inheritance? Multiple inheritance means I have a class A, I have a class B, and it's a very simple thing. It's not a very big deal also. You can use your common sense as well. Okay, you have a class A, you have a class B, you have a class C. So let's say class C extends class A and class C also extends class B, which is called as multiple inheritance. Class A, inside class A I can have a function, let's say use break, and we will have a class B. Okay, and we will have a class C. Cool. Now let's take an example that use break is present in class A and I have also this function called use break in class B. So now when I create an object of class C, which is C obj is equal to new C, what happens when I create a new object of class C? So basically when I do C dot use break, I can do that because it is inheriting from A. So you can use it as extends A comma B. It is extending both the classes. So when I use C dot use break, now the program will get confused that which use break should I use? Should I use the use break from class A or should I use the use break from class B? So there is a confusion that which use break should be used, and that's why to avoid this confusion Java says no, we don't support multiple inheritance. Alright, but don't worry, there is an example, there is a thing called interfaces with the help of which this multiple inheritance can be achieved, but the functionality will be different. It doesn't go like this. That we will understand in some other video. That's not the scope of this video. So I hope you understood the diamond problem and what is the problem and how you can solve it. You can solve it using interfaces, as simple as that. Cool. Okay, let's talk about our next topic, polymorphism. Polymorphism is basically the ability of an object to take many forms. The same method can have different behavior. It's very simple, it's not very complex. You can understand it with a very simple example. Let's move ahead. Okay, I can take this new screen, just take a divider. So polymorphism means many. Okay, poly means many. Alright, polymorphism can be achieved with the help of two things. So basically there are two types of polymorphism. I can explain you that first of all before moving ahead. Polymorphism, one we call it as static, or you can also call it as compile time, or you can also call it as function overloading. Another one is dynamic. You can also call it as runtime. You can also call it as function overriding. Okay, so you can have all of these three in your notes. Now let's try to understand what is static and how does it work. I am not getting a new screen, I don't know why. Let me check. Alright, okay, now I have a new screen. Cool. So let's try to understand first of all static polymorphism. It's a very simple thing, no need to worry, very common sense. Let's say you have a function called void, we have a function called do sum. Okay, and I want to do a sum of two variables, let's say int a comma int b. Okay, and it will do some sum. Similarly, I can have one more function called as void do sum, and I can have int a, int b, int c. I can have three variables over here. Now you can see what is happening over here. The name of the functions are same, do sum and do sum. What is the only difference? The number of parameters which is accepting, int a, int b, int a, int b, int c. So at the compile time itself, when the program is compiling, the Java compiler will know that okay, I have two functions with same name but different parameter. It is function overloading, and here I need to do a plus b plus c, and here I need to just do a plus b. Simple as that. This is called as function overloading. Now we will talk about function overriding, or the dynamic one basically. Alright, cool. So when we talk about dynamic, we need to have inheritance in place. So for example, we have a class A. Let's define a class A, and in class A we have certain function that use break. Okay, now the thing is the return value of use break will be different. Let's say it is returning a true or false, that it is done or not. Then I have class B which extends A. This is only, so this is called as function overriding. This is only possible when we have inheritance in place. So when class B extends class A, and when I use break, I can override the functionality. Are you understanding what I can do? I can override the functionality. I can have some other implementation of use break, and I can return some other thing, probably return string breaks used. So this is what we call as function overriding. Alright, so a very simple, a very typical example. Alright, so we have covered what we have done in this video. We have covered the overview of the OOPS. We have covered the procedural programming in OOPS difference, objects and classes, data abstraction, encapsulation, inheritance and polymorphism, each and everything whatever we have discussed. If you still have any doubt, I'm open to comments, and I reply to everyone, so don't worry and give your doubt. And if you have liked this video, do consider it as subscribing or liking, whatever it takes. It gives me a little motivation. Alright, so thank you for everything. We'll meet in the next video.